Today we are going to look at the confidence interval for a proportion. We're also going to look at how to determine the sample size, look at the margin of error, and then solve some problems. So what the confidence interval means is that, remember, we use sample because sometimes it is very difficult to get the population, or sometimes it's very expensive to even use the population. And so we use the sample. So let's look at a quick example. So let's say that in this class, the total population of people here is 30. Okay. So this class, we are 30. And then I use a sample of, say, maybe I randomly choose 8 students from this class, and then I determine their average height. So I am interested in knowing the average height of students in this class. So let's say that the average height is 5.7. This X bar here, which is the what? The mean height of these 8 students, is based on this sample size. But I'm going to infer using this average height here to say that, well, the average height of students in this class is about 5.7. Does that make sense? So this is a small sample size. So that is why we take a sample. We take a sample so that we can be able to make inference on the entire population. Is that okay? It is just like sometimes when it's getting to elections, you see people putting out polls and making predictions and all that. They didn't speak to everybody, but they spoke to some people, or they sent out surveys to some people, and then they are able to make those predictions. Does that make sense? And so the sample size helps us to be able to make inferences on the entire population. Now, the point is that the true average height of students in this class, sometimes it could not be 5.7. Does that make sense? This is just trying to what? Make an inference or make a guess based on this. So what the confidence interval says is that, well, it's like a range. So for example, the range could be between, say, maybe 4 to 10. So within this range, the true average height of the people in this class would be between this range, given a certain what level of what confidence. So the confidence interval is like a range where we have some level of confidence to say that, well, then the true estimate of the population parameter is within this range. So a quick example to be able to explain that is, for example, you survey 100 students in upstate and finds that 60% drink coffee. This 60% is based on this 100 students you surveyed. Does that make sense? Good. And then you calculate the 95% confidence interval to be within this range. So what it means is that we are 95% confident that the true proportion, this true proportion is not the 60%, is the entire student in upstate. Is that okay? Does that make sense? That the true proportion, so the true proportion is what? P. This 60% here is what? P hat. Is that okay? That the true proportion of all students, you see, all students, not the 100 students. Does that make sense? That the all that what all students what who drink coffee is between this range. Does that make sense? So it means that you are 95% confident, and then that means that the true proportion could be 65%, could be 68%, but you are sure, you are 95% sure that what it is between this range. Does that make sense? So that is what the confidence interval means. So it's very important that you understand what it means and also try to give an appropriate interpretation of that. Now we are going to look at how do we calculate the confidence interval. So we calculate the confidence interval using this formula. So I broke it down. I don't want you to get confused. Remember, the confidence interval is like a range. So when you look at this one here, this is the lower, this is the upper. Is that okay? So to get a lower range, you do p hat. So this gives you the lower range. Is that okay? And then this gives you the upper range. So if you want to make stuff easy for yourself, you are better off to write this formula. Is that okay? It's the same thing. So here is what plus and minus. I don't want you to. So this is the same. If you see this in the book, it's the same thing. But then I went ahead to break it down for you. This is the lower side, and this is the upper side. Is that okay? Good. Now, this SE of P hat is the standard error. So just know that. Is that okay? Remember, the formula has standard error of P hat, and the standard error formula is given by this. We spoke about this last week. And then the Z is the critical value. We know how to compute Z from previous chapters. And then we are going to look at examples and answer this problem here. Now, I just want you to understand that if the level of confidence increases, so the confidence level is like, say, maybe 95%, could be, for example, look at this one here. The confidence level is what? 95%. Is that okay? You could also be 90%. You could be 99%. You could be 98%. So that is the what? The level of confidence. And so if the level of confidence increases, the confidence interval gets wider. We will look at whether this statement is true. We are going to verify that fact. So the most important thing is to make sure that you are able to get the formula for the confidence interval correct. Is that okay? So we have this one here. And then don't forget, the standard error is given by this. So you should also know that. And then the Z you see here is the critical value. We are going to look at how to read that. Okay. Now, let's take our time to read this problem. We'll use StatCrunch to solve that. But before we proceed, I wanted to ask you if we have say 2 and then 5. So let's say this is A, and then I have 0.4 and then say 8, and then this is B. My question is, between A and B, which of this interval here is wider? Why do you think it's B? Yeah, so you see the so the other thing you could see, for me, what I do, which of this could accumulate more numbers? It's B, so it's wider. Is that okay? So if they say something is wider, so if they give you two intervals and they ask you which is wider, this is how to be able to compare that. Is that okay? So you agree that B is wider, right? Okay, good. And you've already written this formula down. Okay, so we'll be able to verify this fact here using this example. So this example says that Watoga Democrats polls a random sample of what? 330 voters. So from here, we can see that N is 330. Do we all agree to that? And finds 144 who said they will vote yes on an upcoming referendum to increase school funding. So it means that they find the number of people who are going to vote yes. So like the number of successes. So that is what? 144. Then the question says that we should create a 98% confidence interval for the percent of all voters who support the referendum. So to be able to do that, let's open our StatCrunch. So when we are at StatCrunch, we go to stats and then proportion stats. Open StatCrunch, go to stats, proportion stats. Is that okay? And then we go to one sample and then we click on with summary. Stats, proportion stats, one sample, and then with summary. I recommend that you take part in everything we do here. That way you learn how to do it. Is that okay? Should I proceed? Okay. We'll click on this here. Is that okay? So now, what is the total number of observations? 330. Is that okay? And then we are told that they find that 144 will say yes. So the number of successes, their success is people who are going to say yes to the referendum. Is that okay? So the number of successes is what? 144. Is that okay? Does that make sense? Okay. So now change the hypothesis to confidence level. The number of observations and then 144, then change the hypothesis to confidence level. What is our confidence level? 98. In the problem, they say create a 98% confidence interval, isn't it? So let's change this 0.95 here to, what should we change it to? 0.98, good. Is that okay? And then all you have to, so when you do this, I always recommend click on this one here, show critical value. You would always need that. Is that okay? So always click on show critical value. The reason why I say this is that there are some problems you just want the critical value. So if you just want the critical value, you can just put anything here, put the confidence interval right, and show critical value, and then pick that critical value and then go use it. Does that make sense? So always show critical value, and then let's hit compute. So now it is very important that you understand what this stuff mean here. So you can see that the sample proportion. So what that means is that this sample proportion is the same thing as what? Okay? So always know sample proportion is p hat. Is that okay? Good. Then standard error, this is what? SE of p hat. So this is the what? The standard error. Is that okay? Critical Z. So this is the what? The Z value. And then we are interested in the confidence interval. So the confidence interval has been given to you. This is the lower limit. This is the upper limit. Is that okay? And for confidence interval, you have to be able to write it properly. We always write the lower limit first. You cannot write a confidence interval, say 5, 2. This is incorrect. Is that okay? It should be the smallest number and then the bigger number. Is that okay? Good. So you can see the confidence interval here is what? 0.3728, 0.4998. Okay. And then this is for what? 98% confidence interval. And what is our Z? Our Z is what? 2. 3, 2, 6, 3. Does that make sense? So start crunch gives you this straight away. So now let's try to change the level of confidence and see. Now let's go to options, click edit. So options, edit. Instead of 98, let's use 90. Is that okay? Instead of 98, change the level of confidence to 90. If we change it to 90, now, same thing, you would realize that sample proportion is the same. Standard error is the same. What changes is the critical value. Is that okay? And then because the critical value changes, now look at the confidence interval. The confidence interval is what? 0.3914, 0.4812. This is for what? 90%. And then our Z is 1.6448. So you can see from here, when you increase the level of confidence from 90 to 98, you can see, look at the confidence interval here. You see here is wider than here. Can you see that? So then this goes to say that what? If you increase the level of confidence, your interval gets what? Wider. Does that make sense? Good. I want you to open chapter 16 homework. Let's get to 17. So when we are at 17, spend time to read. So let's try to focus on mine, and then you could also do yours. Now, what is N? What is the sample size here? 100,000, right? Okay. So N is 100,000. Good. Now, what is the number of successes here? Okay, 5,325. Okay. And what is the level of confidence I'm trying to compute? So we are asked to find what we should give a 99% confidence interval for the true population of the what from those for the entire mailing list. So we could use StatCrunch to do that, isn't it? So let's get to StatCrunch, and then we go to stats, proportion stats, one sample with summary. Okay. And then I think mine should be 5,325 here, isn't it? Can you see that? And then my N is 100,000. Is that correct? And because I want the confidence interval, I come to what confidence interval for P. What did they say I should do? They asked me to find the what? 99, isn't it? So 99, it means that here has to be what? 0.99, right? And then I hit compute. So this is the range, isn't it? Now, when we come here, it says that here is percent, here is percent. You see? So it means that you have to multiply your answer here by 100. Do you get what I mean? So what do you think the lower should be? So they want two decimal places. So the lower should be what? So two decimal, I think 5.1. Let me see. 5.14. Yeah. What do you think the upper should be? . Mm-hmm. 5.51, right? Do you all agree to that? Okay. Now, the question they want to ask is, given this interval, right, you found, is the proposed true P. So they are assuming that this is the true P. Is this true P within this interval? Yes or no? Why is it yes? Now, this is 5.5. Okay? So to be able to do that, you could draw a number line. This is 5.14. This is 5.51. 5.55 is around somewhere here, isn't it? So it's within. Do we understand that? Good. Okay. Now let's move to question 18. Before we do question 18, let's say that you get confused. Let's come to edit. And then maybe you try to switch this. Say you put 100,000 here. And then say you put 5325 here. Remember, proportion can never exceed 1. If I want the number of students who like apples in this class, the maximum I could get is everybody likes apple. That's going to be 1. Is that okay? So you see, when you click on this, the number of assessors cannot exceed the number of observations. Is that okay? So when you click on this, it gives you an error. Does that make sense? Good. Now let's get to 18. So 18, what is the number of observations? 138. And what is the number of success? 33. Okay. And then what is the confidence level? 0.9. And then it computes that for us. Okay. You should be able to know this is the lower limit, this is the upper limit. This is the standard error P hat. Is that okay? And then you could be able to now input everything here. Any questions on how to compute that? So you have the formula. You could also use that too. Is that okay? Good. Now let's proceed. So it's the same thing like we did. You just have to input them. Let's proceed. So now we can create confidence interval and then also interpret them. So for example, you see the one we created where we had this and then that. So we could say that what? We are 98% confident that the true proportion of voters who support the referendum falls within this range. Is that okay? That is how to interpret the confidence interval. You'd have a lot of homework problems on interpreting the confidence interval. So it's very important to do that, to understand how to do that. So, for example, you see here, we are entering the number of students or the number of people who are going to vote yes on the upcoming referendum. And then these are confidence interval. So you see, there's the confidence level. We are 98% confident that the true proportion of voters who support the referendum falls within this range. Is that okay? So even you can see that the referendum won't pass. Why won't the referendum pass? Can anybody try? Because looking at this interval, you need more than 50% for the referendum to pass, isn't it? Does that make sense? Look at this interval. 50% is outside of this. So you can even see that the referendum won't what? Pass. Does that make sense? Now, the next thing we want to talk about is the margin of error. And then the margin of error is given as Z times the standard error. So you should also write that down. The margin of error is given by Z times the standard error. Now, the margin of error is also related to the confidence interval. Now remember, let's look at this formula here. What did we say the margin of error is? It's Z times the standard error, isn't it? Can you also agree that when we look at this formula here, in place of Z times standard error, here I could put the margin of error. Do you agree to that? This is the same thing as the margin of what? Error. Does that make sense? This thing here is the same as the what? Margin of what? Error. Okay? So based on this, you can agree with me that the confidence level is given as P hat minus margin of error, P hat plus margin of error. And then margin of error is given by this. Do you all agree to that? So this is the same thing as what? The confidence interval, isn't it? Just like the first one you wrote down. So just know that. Now, based on this, the more confident you want to be, it means that then the margin of error must also be a bit wider. So there are some problems that is going to ask you to compute the margin of error. So for example, you realize that when we went to StatCrunch where we had, if they wanted to compute the margin of error, when we went to StatCrunch, we had Z, we had a standard error. You just need to put them here and then multiply to get the margin of error. Do you get what I mean? So for example, let me try to do. Um, for example, they want to compute the margin of error. You can see margin of error is what? Z times the standard error of what P hat. Is that okay? So from here, what is our Z? Okay, I didn't click on that one to show Z, but I tell you to click to show the critical value. Is that okay? So you put that critical value here times the standard error, which is what? 0.036. Do we see that? So always try to what? Show the critical value, and then you can just multiply from here. Does that make sense? Okay. Now we are going to look at some examples. So Now we are going to learn how to determine the right sample size. So for example, if you want to conduct a study, what sample size should you choose? And then, so I took the pen to be able to, I'll teach you how to solve that, but I recommend that to determine the sample size, always write this formula down. This N here shows you the sample size. And this formula was derived based on the margin of error. So I was already recommend that you write this formula down. Is that okay? You know what P hat is, you know what Q hat is. Remember, Q hat is what? 1 minus P hat. We learned this last time. So how did I get this? So for example, we know that the margin of error is given as Z times the square root of what? P hat Q hat over N. The standard error is given by this, so that way. Is that okay? And because I want to determine the sample size, I make N the subject. Is that okay? So to make N the subject, let me divide both sides by Z. Is that okay? So divide both sides by Z. If you divide both sides by Z, you are going to get margin of error divided by Z equals P hat Q hat over N. Do you all agree to that? What should I do next? Any idea? I want to take away the square root. What should I do? Square both sides. Is that okay? So the next step is to what? Square both sides. If you square both sides, you get margin of error over Z squared equals P hat Q hat over N. Because if you square both sides, the square and the square root will cancel. Is that okay? Now, what do I need to do? You could multiply both sides by N. Is that okay? So now multiply both sides by N. If you multiply both sides by N, you get N times. Okay? And then because I want N, you divide both sides by what? Margin of error divided by Z all squared. If you do that, you get this. Is that okay? So this is how to determine the appropriate sample size. Let's look at an example. So in this example here, we are told that the EU reports 46% of its workforce is female. The US Department of Labor wants to calculate a similar statistic. How many records? So that is asking you what is the sample size? Is that okay? How many records should this sample to know the percent of females in the labor force to be within 5% with a 95% confidence? Is that okay? So based on this, to be within this, it means that our margin of error is 0.05. Does that make sense? So margin of error is 0.05. What is our p hat? Our p hat is what? 0.46. Okay? Now, remember the formula is what? N equals p hat Q hat all divided by what? Margin of error over Z all squared. Right. We have our P hat. What is our Q hat then? Q hat is what? 1 minus what? P hat. Is that okay? So that's going to be what? 1 minus 0.46. What would that be? 0.54. Good. Now we need our Z. Okay? What is our Z? Go to StatCrunch and then tell me the Z. So based on the example we did, just change the Z to be 90. So if I were you, whenever I'm giving something like this, all I have to do is to come to StatCrunch. Go to StatCrunch. You could put anything here. I could put 30. I could put 150 or 159, anything. Is that okay? I want 90% confidence. So I just choose show critical value. Is that okay? So when I show critical value, and then I make sure here is what 90, I click on this one here. So my critical value is what 1. Z is what 1.64485. Is that okay? Does that make sense? You see, I want to pick the Z. Okay. So now let's proceed. So now we have this one here. Now look at how I'm going to solve this. I take my time. I find margin of error divided by Z. Margin of error is 0.05 divided by Z, 1.64485. Do this on calculator and tell me, what do you get? What do you get? So I got 0.03039. Did you get that? Okay. The next thing I want to do is to say, okay, you could spend time to also do, well, margin of error divided by Z all squared is the same thing as what? 0.03039 all squared. Okay? You could square this. If you square that, what do you get? I got 0.000924. Okay? And then now let's solve for our n. Our n equals, what is our p hat? 0.46. What is our q hat? 0.54. All divided by 0.000924. What is n? So I got 268.83. Now the sample size cannot be decimal, so you round it to the nearest whole number. So n equals 269. Does that make sense? So you see how I solved for the sample size implementing the formula. Is that okay? Good. Let's try one more example. So let's do this one here. So same thing. I won't spend much time on this one, but you can see from here, same thing. Our margin of error is, what is the margin of error here? What is the margin of error? That is the margin of error. Is that okay? What is our p hat? So you see, how many cars should they sample if a primary result gives 10% of the car? So p hat is what? 0.1. Does that make sense? So if p hat is 0.1, what is q hat? 0.9. And then you can use stat crunch to get the z. Does that make sense? And then you come and just what? Implement the formula. Is that okay? So let's try to do question 14. Let's see. I think there was one that asks you to compute the sample size. Let me see. Okay, let's go to 18 and then let's do B. 18B. Is that okay? I want us to compute this sample size. Is that okay? So let's do 18B. So 18, we can see from here, when we go to start crunch, we go to start, proportion starts, and then with summary here. And then we can see from here, we can see from here that this is what 145 and then this is what 30. Is that okay? So we come here 145 and then this is what? No, this is 145 and then this is 30. Right? 145 and then this is 30. Is that okay? And then the confidence level is what? 90. So you can see from here, confidence level is 90. Can we see that? Then we click on show critical value. Is that okay? Good. And then we click compute. We have this one here. Now, the question says that if the scientist wants to cut the margin of error in half, how many deer must they inspect? So how many deer? It means we are interested in computing the sample. Is that okay? So the first thing we want to do is to write out the formula for the sample size, which we already know. So then that is going to be, we have our n to be p hat, q hat, all divided by margin of error divided by z whole square. Is that okay? So now when we look at this thing here, we can see from here that p hat is 0.20689. Q hat is 1 minus 0.20689. What do you get for Q hat? Use your calculators and then tell me. What? 0.79. Do you have some decimals? 311. So we are told that a scientist wants to. So now here, what is our Z? We can see from here, our Z is 1.6448. Now we are told that we need the margin of error. The scientist wants to cut the margin of error in half. First and foremost, what is the margin of error? Margin of error is equal to what? Z times the standard error of P hat, isn't it? Is that okay? Okay. So here, this is our Z 1.6445 times standard error. Okay? 0.0336. When you multiply them, what do you get? Let's be fast. Time we are fast behind time.
0.0055.
0.0055. We are told that the scientist wants to cut this margin of error in half. What do you think we should do? How do you cut this answer in half? You divide by 2. Is that okay? So then for the scientist, margin of error is equal to 0.0055 divided by 2. Pick that answer and come and plug everything here. So we are going to have 0.20689 times 0.79311, all divided by, if you divide this by 2, what do you get? If you divide this by 2, what do you get? 0.275. So 0.00275 divided by Z 1.64485. That's how to do that. Is that okay? So I'll see you on Wednesday.